Hi students, this is problem number 7. A current of 10 ampere is flowing in a wire of length 1.5 meter. A force of 15 Newton acts on it when it is placed in a uniform magnetic field of 2 Tesla. Now the angle between the magnetic field and the direction of the current is to be found. So when a current carrying conductor is placed inside a uniform magnetic field, it experiences a force, and that force is given by F is equal to BIL into sin theta. So BIL into sin theta. Now in this case, I will write the sin theta, I will find out first. So sin theta is equal to F divided by BIL. F divided by BIL. So here B is equal to 2 Tesla. B equal to 2 Tesla. Current I is equal to 10 ampere. So this is a 10 ampere. And the length L is equal to 1.5 meter. And the force acting on it is 15 Newton. So F is equal to 15 Newton. So just if you substitute, what is sin theta equal to? So instead of this F, so F is 15 divided by B into I into L. So 2 into 10 into 2 into 10 into 1.5. So this is equal to 15 divided by 2 into 10 into 1.5 is 15. So the 15 and 15 can be cancelled. So this is equal to 1 by 2. Therefore, sin theta is equal to 1 by 2. Theta is equal to sin inverse of 1 by 2. And that is equal to 30 degree. So the angle between the magnetic field and the direction of the current theta is equal to 30 degree. So option A is the correct answer. Okay. Therefore, option A is the correct answer. Okay. Problem number 8. A proton and alpha particle are shot into a magnetic field at right angle to the field with the same kinetic energy. So inside the magnetic field they have the same kinetic energy. Then the ratio of their radii is to be found. Now we have studied magnetic Lorentz force. So when the charged particle is moving perpendicular to the uniform magnetic field, it experiences the maximum Lorentz force, that is given by QVB sin 90. That is QVB. And since it is revolving in a circular path, the magnetic Lorentz force, its magnitude must be equal to the centripetal force. So I will start from the equation QVB is equal to mv square by r. So that this V term and this square term can be cancelled. So I will write an expression for the radius. Therefore, radius r is equal to m into V divided by q into B. So this is the first equation. Okay. Now kinetic energy expression. Kinetic energy of the particle is denoted by the symbol K. I will take only the symbol K for kinetic energy. And that is equal to what? Half into m into V square. I am rewriting the same expression by multiplying in the numerator as well as denominator by the mass of the particle. So this is half into m square V square divided by m. So that the value does not change. So m has become m square, denominator I have divided by m. So this m square V square is what? M into V the whole square, that is momentum square. So here this kinetic energy, therefore kinetic energy is equal to 1 divided by 2m into P square, where P is equal to mass into velocity, that is the momentum of the particle. So m square V square has become what? P square. So this implies P square is equal to 2m into kinetic energy. Or what is now momentum P? P is equal to square root of 2 into m into k. 2 into m into k. So this is another step. This is the second equation. Now in the first equation, mass into linear velocity is called linear momentum. So in place of this m into v, I can substitute this momentum. So mv is equal to square root of 2mk. Therefore, rewriting the first equation, the radius, the radius r is now equal to, instead of this mass into velocity, momentum can be substituted as square root of 2m into kinetic energy k divided by q into b. So q into b. So now you can see in this expression the radius of the circular path depends upon all these factors. But which factors on the right hand side are constants? See, B is constant because it is uniform magnetic field. So B is constant. And kinetic energy also is a constant. They have the same kinetic energy. And 2 is also a constant. Therefore, R is proportional to square root of the mass of the particle and inversely proportional to the charge. Okay. What are the two given particles now? First one is what? Proton. So, for proton is what? Proton is 1H1. So, its charge number Q1 is equal to 1. I will write here Q1 for the first particle is equal to 1 unit and mass M1 is also equal to 1 unit. Then for an alpha particle is nothing but the helium nucleus. So, helium 24. So what is the charge number of helium is 2 and mass number is 4 units. So in place of Q2 I can take this is equal to 2 units and in place of mass M2 I can take it is having 4 units. Okay, 4 units. So Q1 is equal to 1, M1 is equal to 1, Q2 is equal to 2 and M2 is equal to 4. So in this expression, so I can write R1, okay, R1 by R2 is now equal to square root of M1 divided by Q1 into Q2 divided by square root of M2. Now I am going to substitute these values so that now this is equal to square root. I can write square root of M1 by M2. Okay, square root of M1 by M2 I will write into Q2 by Q1 into Q2 by Q1. So this is equal to square root of M1. M1 is 1 and M2 is 4. So this is 1 divided by 4, okay, into Q2 by Q1. Q2 is 2, Q1 is 1. So this is 2 divided by 1. Okay. Now 1 by square root of 4. No, it is equal to what? 1 square by 2 square. So inside the root is 4. It will become 1 by 2 into 2 by 1. So cancelling these 2 on both sides, this is equal to 1 divided by 1. Therefore, the ratio R1 is to R2 must be equal to 1 is to 1. So which of the options is correct? You see here option A is the correct answer. Okay. Therefore, okay, option A is the correct answer. Have you all understood? Okay, fine.